In this video, I want to talk about the DeleteMin operation. So this one's basically following from the min operation we talked about in the previous video, but a little bit more complicated. Given this tree, we already know how to find the minimum variable, right? Just start at the top, go all the way to the left, right, until you reach something that doesn't have a left child. So here, right, we basically know that this is going to be, our minimum, right? We already know that. But what do we do for delete? What could we possibly do? Well, here, right, we basically, so in the end, right, we have to worry about two cases. So the simplest case is what I have here on the screen. So I have just two, no children on either. Right? I have nothing here, nothing here. So what can I do? I can just, throw that out. Easy. Something that's maybe a little bit more complicated is when this has a right child. Okay, I have to take care of that case as well, right? I don't, what do I do, right? This, right, should be moved up to here, right? Basically, I would replace 2, right, with that 3 value, with that right-hand side value. So that's a little bit more complicated. What can we do? Well, in the end, basically, we're going to say is the following, right? So let's say, right, I want to delete this 2 over here. So I want to delete that one. For sure, the left of 2 is null, because otherwise we aren't looking at the minimum. So either right-hand side is null or it's not null. In either case, just put it where 2 is, okay? So if the right-hand side is null, that means that 2 goes away. If the right of 2 has some actual value there, that means we bring it up, right? So in either case, we're good. So those will be our rules. Taking a look at the source code here, right? Again, we have our methods. We have our main one, right? And then our helper, right? And then our recursive one. So again, right, the helper starts a recursive one at the root. And let's just look at the code, right? Here, basically, right, what we're saying is, okay, let's say I do a delete min on this, tree rooted at x, right? If x's left is null, that implies x is the minimum, right? This is what we did in the min function. That means that we just return x dot right, right? So whatever's on the right side of 2, that gets moved up into that position, right? That's what this line here is doing, right? So if I go all the way down to the left to x dot left is null, just move the right-hand side of x, right, back up to the place of x, right? Because x is our minimum, right? We're looking at a tree, right? We're looking at a tree rooted at x, and the root of that tree is our minimum. Replace that tree by whatever is the right-hand side of x, right? So either it's null or it's a particular node. Just move the whole thing up. If it's not null, right, then we have a little bit of work to do. Basically what we do, right, is we say, okay, you know what, I'm looking at a node in the tree, right? So it's like, hey, maybe I'm looking at this 5 over here, right? Maybe that could be where I'm at, right, instead. If I'm looking at that, update 5's left to be 5's left with that minimum deleted, right? So you'll notice we have this kind of paradigm again. The input is that left-hand subtree. We do some stuff to it, and then we update the left-hand subtree. So we saw that before in a couple of the other methods. Basically, the idea, right, is I'm applying some operation to one side of that subtree. And then, right, we have basically the same code we had for put, which is to update n, right? We've deleted a node, right, so we need to basically update, the value of n, right, because now it's going to be 1 less. So yeah, that's our delete min. One side note here, just so people kind of think about it, this is actually about n, right? So somehow, right, what happens when we run this code is the following, right? I have basically, a DeleteMin call to 8, which becomes a DeleteMin call. Actually, I should do an indent there. Indent is the proper thing to do when we're doing recursion. DeleteMin call to 5, and a DeleteMin call to 2. On the way back up, these will actually all run this final line here, right? So this is at the end of my function. So if I think in terms of recursion, right, I have this call happens, right, and this call makes another call, another call, another call, right? I have nested calls. As they complete, they all have to run this last line, right? And so this last line here, right, this one will do, n equals da 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 da, right? That'll update this one. It won't really update it because it's gone, but it's then, right, it'll roll back up to 5, right? That DeleteMin to 5, it'll update the n on that one. Then it'll roll back up to 8, and it'll update the n on that one. So yeah, basically, right, as that recursion unwinds, it'll update that n variable on each of the nodes it visited to get to that minimum, right? So you basically are, updating everything that you visited, right, to get there, because those are all the nodes, right, that have, this node you deleted as an ancestor, and so that means that you'll have to update that n variable with a new size. So yeah, just keep that in mind, right, in terms of recursion, you're updating everything that you visited on the way there. All right, so that does it for delete min. It's very similar, right, for min, right? It's very easy, right? You just find the left-hand side, and then once you find the leftmost element, right, you just kind of replace it by whatever its right-hand child. So yeah, that's delete min.